Hello students, so today's topic is dispersion of light by prism. This part is not visible due to reflection of light from the front light. So please avoid this one. This is your reflection, this is your light by dispersion of light by prism. So let's start. What is prism? In maths, we already discussed that if we take any 2D surface and raise up to a height, that one is known as your prism. Clear? So in physics we are using triangular prism. And what is the three-dimensional figure of prism? Suppose we have a triangle. Clear? And we give some height to this triangular part. So this is a two-dimension figure of prism. This angle is known as your A. This is vertex angle and also known as your angle of prism. This one. That angle of prism is always opposite to the base. If you tell this one, the same figure we obtained. This is the quality of prism. Definition says that a prism is a piece of glass or any transparent material which is bounded by two triangular surface and three rectangular surface as illustrated. Means this one. There are two triangular surface and 1, 2 and this bottom part 3 is your rectangular surface. This is known as your prism. The rectangular surfaces are called refracting faces. The angle between two refracting faces is known as your angle of prism. Means what? These rectangular part, this one and that bottom part, this one is known as your refracting faces. An angle between two refracting face is known as your angle of prism. Angle of prism. But in physics or in ray diagram, we not use this type of figure for prism. We always use the cross section figure. Means we use an equilateral triangle. We must draw an equilateral triangle and this represents the prism. This is your angle of prism. This is your A angle of prism. Suppose this part is your A, B and C. Now what is the work of prism? Suppose a light of ray travel from medium. This is a transparent material, this is a denser medium and this is outside the prism, there is air. So if light ray travel from air and incident on first rectangular face of prism, what happens? There is a deviation of path. Let me draw this one. Clear? There is some deviation of path. Light rays shift towards normal by obeying the laws of reflection. Clear? For the prismatic cases, this is your imaginary normal, this is your angle of incident and this one is first angle of refraction. Now light inside the prism, light ray travel state, because by obeying the laws of reflection this become a little bit straight, tilt towards normal, move away, or sorry students, this one is your angle I. Now after that, light ray travel from denser to rarer medium, again shift away from the normal. So this is your angle of second incidence. It can say this your angle of second incidence, or some will say it's a R2, it's a R1, or this one is your emergent one. Why? Because this emerged from the one ray. This is known as your emergent ray. Incident ray, this is your refracted ray. This one is your refracted ray, but we are not going to mention this one. And then after first refraction, it fall on for a second refraction. We give the name of this angle R2. Actually this is a second incident ray, but we give the name of the angle is R2, and this is your emergent ray. We give the name E. Now this is the basic construction of prism or working of prism. Prism work on the laws of refraction, and there is a formula for prism that angle of incidence I plus angle of emergence, that E is always equals to angle of prism A plus angle of deviation. So all things known by you, but what is angle of deviation? D for deviation. What is angle of deviation? Actually deviation means change of path. So in this case, what is the actual path, original path? This one, let me use some scale of I am using this one for showing you. This is your actual path of light ray, na? But light travels and changes to this direction, na? So this is your final path of light ray. Clear? This is your final path of light ray. So angle between this ray and this ray, this angle is known as your angle of deviation. I hope this thing is clear. This angle and this angle made by these two, not the inner part, it's the outer one. This angle is known as your angle of deviation. So this plus this means all exterior angle are equals to all interior angle, that is angle A plus angle D. These two are interior, na? So always remember this one, angle of incidence plus angle of emergence is equals to sum of angle of incidence plus angle of emergence equals to angle of prism plus angle of deviation angle. Means internal angle equals to external angle. Sum of internal angle equals to sum of external angle. So that is this one is the laws of reflection. Hope this thing is clear to you. Now this is known as refraction of light or dispersion of light. Actually it is not dispersion. What we discuss, it is a refraction of light. It is refraction of light by prism. Now we are going to discuss about dispersion of light by prism. So what is the dispersion of light by prism? Actually, when a white light ray emitting from a point source fall on the first refracting phase of prism, clear? First refracting phase of prism, this white ray bipart itself into 7 different rays, colors likewise. 1 2 3 4 5 6, this one 7. Clear. Inside the prism, this thing happen for case of white light. Always remember, this is your white light, incident rays from white light, and this is from a single ray. Clear. And after second refraction, they produce a band of 7 color. They produced a band of 7 color, and these color will read from the bottom to top, known as your Vibgyor. Bottom from top, it's a Vibgyor. It's a violet, indigo, blue, green, yellow, orange, red. So you can write down red, orange, yellow, green, blue, indigo, and then violet. These are the bands of color combination of a white light. Single ray white light deviates into 7 different color. This one is known as your dispersion of prism, and this band is known as your spectrum. Band of 7 colors are known as your spectrum. Why this thing occur, this thing happen in this case? Always remember that in air or in rare medium, the speed of these different colors are almost same. But as soon as they suffer the first refraction, the speed of light, speed of different colors are different. So they change the direction according to their speed. Means those who travel those who travel more faster, it turns more, and those who travel less, it turns less. Right? No, actually this also depend on wavelength. The angle of deviation produced by a colored light depends upon its wavelength. The less the wavelength, the more is the angle of deviation, and vice versa. Means less the wavelength is less, so angle of deviation is more. For in this case, indigo is less wavelength. Less wavelength, so more deviation. Less wavelength, let me write this one. Less wavelength, more deviation. This one means it's a inversely proportion. It means what? Red has a high wavelength, it's a less wavelength. It's a high wavelength. So there is less deviation and it travel in a straight, almost less deviated and reach up to us. So this is a high wavelength, this is your less wavelength, and all are lie in between these two. So this is a little bit introduction of your topic. In next class, on higher class, we must discuss the new thing. Thank you for this video.